FastMCP 3 implements dynamic component visibility through server-level enable-disable transforms that filter tools based on tags and keys. This runtime access control mechanism allows selective exposure of functionality while maintaining modular organization through mounted servers and namespaces. The upcoming code demonstrates how to mount a subserver under a namespace, define a tagged tool, and apply global visibility rules to disable all components with specific tags. You'll observe the disable method operating at the server level to filter out internal tools across all mounted providers. From FastMCP, import FastMCP. Main equals FastMCP main. Main, mount subserver namespace equals API. At main, tool tags equals internal. Def local debug, SDR. Return debug. Hash disable internal tools from all sources. Main, disable tags equals internal. This code demonstrates server composition and namespace organization in FastMCP 3. The main server mounts a subserver under the API namespace, creating a hierarchical structure where the subserver's components become available through the parent. The namespace prefix prevents naming conflicts when combining multiple servers, which is particularly valuable for modular applications where different teams or domains need isolated component spaces. The example also shows runtime visibility control through the disable method with tag-based filtering. By tagging the local debug tool as internal and then disabling all components with that tag, the code implements a feature flag system. This approach allows dynamic adjustment of available functionality without code changes, useful for access control or progressive feature rollouts. The server-level disable overrides any provider-level settings, giving the main server final authority over component visibility. The combination of mounting with namespaces and tag-based visibility control creates a flexible architecture for large applications. Developers can organize related functionality into separate servers, mount them under appropriate namespaces, and then manage access at runtime. This pattern supports both modular development and runtime customization, though it requires careful tag management to avoid unintended visibility changes when multiple tags are involved. Let's break it down. From FastMCP, import FastMCP. Imports the FastMCP class from the FastMCP module, providing access to FastMCP server functionality for creating and managing MCP-compliant servers. Main equals FastMCP main. Creates a FastMCP server instance named main that will be identified as such in MCP protocol handshakes. The string main serves solely as a server identifier for client recognition during protocol interactions. Main, mount subserver namespace equals API. Mounts the subserver into the main server under the API namespace. This makes all components from subserver available through main, with their names prefixed by API for tools prompts or /API/ for resources templates to prevent naming conflicts. At main, tool tags equals internal. Def local debug, SDR. Defines a tool function named local debug that returns a string, decorated with @main tool and tagged as internal for MCP protocol visibility. The decorator exposes this function as a callable tool in the FastMCP server, with the internal tag indicating it's meant for internal use rather than public access. The function signature shows it takes no parameters and returns a string value. Return debug. Returns the string literal debug as the output value of the current function or method. Hash disable internal tools from all sources. Main, disable tags equals internal. disables all components tagged with internal across the entire FastMCP server instance. The disable method filters out any component that has the internal tag, making them unavailable for client queries or execution. This operation affects all component types, tools, resources, templates, prompts that carry this tag. FastMCP3's server composition and tag-based visibility control work together to create a modular yet flexible architecture. By mounting the subserver under the API namespace, you establish a hierarchical structure that prevents naming conflicts while maintaining logical organization. The tagging system then enables runtime access control, where the disable method filters out all components marked with specific tags, like internal, across all mounted servers. This combination allows you to dynamically adjust functionality without code changes, making it ideal for feature flags or access control. The key trade-off is the need for careful tag management to avoid unintended visibility changes when multiple tags are involved. Ultimately, this pattern supports both modular development and runtime customization, giving the main server final authority over component visibility.
The namespace wraps the server, but the client calls the tools by their old names, and they still respond.